All right, so are you ready for some fighting? Not woo, yeah or no, you don't want to fight? Are you ready for some fighting? Yeah. All right, great. Welcome to the Telemetry Showdown. Fluent Bit versus the OpenTelemetry Collector. So let's press start. My name is Henrik. I am a cloud native advocate working at Dynatrace. So I spent about now 4 years working on Dynatrace, more on open source related stuff. And inside of that, I'm a CNCF ambassador since a bit more than a year. And yeah, since 4 years, I'm just enjoying being part of this amazing observability slash cloud native community. It's just a warm, welcoming community. I love it. But prior to that, I spent my entire career as a performance engineer. So testing, breaking, tuning, and breaking is so fun. You know, when you kill something, you're so happy about it. Especially the systems. So that's why I still love performance engineering. You'll see that this presentation is going through that direction. So if you're looking for content related to just performance engineering methodology, there's a podcast / YouTube channel called PerfBytes, where I try to build content when I have time. And otherwise, I have started a bit for less than 4 years now, a YouTube channel called Is It Observable? So yeah, you have it in a name. It's about observability. So small disclaimer before we start. So I did lots of tests to fulfill to get all the results that we're going to present today. And I can guarantee that I have been very gentle with the birds, the telescope. None of them was being harmed. I mean, sometimes they just crashed. But I didn't do that by purpose, so I can guarantee that. The intention of this talk is not to blame any of those community or any of those products. In the opposite, I'm a big fan of the Fluent Bit community. I'm a big fan of the OpenTelemetry community. That's just wonderful communities in general. So here it was about sharing feedbacks during those tests. And more than that, for those who's using agents, maybe give some recommendation about which agent you should use. All right, so let me introduce the fighters. Ladies and gentlemen, boys and girls, on the right side corner, we have Ryu from the Fluent community, and he's been trained all his life by his big brother, Fluent D, which is basically doing a lot of logging processing. So Fluent Bit, when he was born, he was basically he had already that culture of logging. And because initially when Fluent Bit was being built, it was designed for edge devices, IoT. So very small footprint, very efficient to process. And since Fluent Bit version 2, they had the support of metrics and traces. That's why we have this benchmark today. So the opponent is on the right side of the corner, which is Ken from the OpenTelemetry Dojo. He's been born initially with the support of traces, and then he followed the support of the signals that the OpenTelemetry project has been covering. So of course, metrics first, and last logs. And now if you check it out, you have experimental support for profiling. So if you're interested, you can try to use the collector for that. So how we're going to present this benchmark? A couple of things. I'm going to cover first the design experience using those tools. So explaining the design, the logic behind those agents. And then we will cover specifically for each signal's logs, what are the features that they cover, traces, and metrics. And last, we will look at those benchmarking results in terms of resource usage. All right, let's go. Round one. And here you say logging. No, sorry. You see design. Round one. Oh, there's low energy in the room here. Gosh. All right, let's start. So as any telemetry agent, the idea is going to be a process starting. It would load a file, a configuration file. And in fact, that configuration file will hold your actual pipeline. And the pipeline defines what you're going to do with the data, how you're going to process it. And the structure of the pipeline are obviously different depending on the tool. So if you look at Fluent Bit, they have this 4 boxes. So technically, it's 4 different threads. So you have the input threads to receive. Then you got to go to parser, then filter, and last you jump into output. So the plugins will be following the orders. Since Fluent Bit version 2, they introduced this notion of processors. And the processor is an amazing concept. The idea is that you can connect to the same thread as the input to start processing the data, which means I receive something, boom, I'm changing it. And then it goes to the other part of the pipeline. And you can all do the same thing as before, just emitting your logs to the backend. You can do a final transformation in the same thread as a processor to send it. So that is pretty new change that Fluent Bit community has introduced. The collector, on the other hand, has different naming, but it's quite obvious. So he has receivers to receive, he has processors to process, and he has exporters to export. And then you have this notion of connectors. Connectors is pretty a very amazing component. Connectors behave like a receiver and exporter, so I'm receiving traces, I'm going to transform it as a metric, and I will send it back as an input into a metric pipeline, for example. And then you have the extensions. Extension is a way of extending the behavior of the collector. So it has a different color because it doesn't have access to the data. So basically, it's just like enabling features. In terms of the pipeline itself, the collector, the logic of input, the logic that I presented before is exactly going to be the same for each signals. So logs, traces, metrics, and for profiling, it's always the same. No differences. Of course, the plugin that you pick and choose will have specific support for specific signals, but the logic is the same. When it comes to Fluent Bit, it's clearly different. If you look at the logs, logs has this notion of parsers and filters, because it's basically an heritage from Fluentd. And then you don't have that in metrics and traces. So the way you're going to define your pipeline, it will be in metrics and traces. You cannot take advantage of the parsers and filters, meaning that all those plugins that are pretty amazing on the filter and parsing side would only be very supported logs and nothing else. So you will have a limited number of plugins available. The other thing that Fluent Bit is quite interesting in that sense is this notion of tagging. When you receive data, so for example, I'm receiving kubelet, I will tag it kubelet. And then if I receive logs from Kubernetes, I will tag Kubernetes. And the purpose of this is to simplify the actual design. So then if I do a plugin, let's say I want to parse specifically the logs from kubelet, I say, oh, match that tag. So you're basically selecting which type of content where this plugin will be applied. So it avoids to putting very complexity in the pipeline, like if then else or switches. So it's pretty does the job. And at the end, you have a very lightweight with a couple of lines. You can do very, very complex things in Fluent Bit. The collector doesn't have that tagging approach. So this is where connectors comes in the picture. So if you have logs from Envoy and traffic, and I want to parse it differently, then I will use a routing connector where I put, oh, this comes from traffic, I will trigger the pipeline for traffic. Or this comes from Envoy, I will trigger the pipeline for Envoy. So at the end, you can do as complex things. It's just that you will have, at the end, lots of pipelines. One for kubelet, for example, one for Envoy, so then in the end, the files that you will manage with the logic will be much, much, much bigger than the others. On the pipeline format, Fluent Bit went through a transformation. It went through this old TOML approach where you have a section input, and then within the section you say, oh, a name, I'm going to use a specific plugin, so here tail, for example. And then you configure the plugin. And then the actual logic is pretty much sequential. It follows the order. And since Fluent Bit version 2, since they introduced the notion of processor, they went through a YAML format. So if you're using Fluent Bit, and you're still in the old TOML format, then it's time to change. Because you're not able to use this multi-thread approach. So YAML will be your best friend for that, for sure. On the collector, the logic is different, where here you're going to basically list. So you don't put the actual flow of your processing. You say, oh, I have some receivers, and you list them without any, basically, connection. You configure them, of course. Then you go do the same for the processor. You do the same for the exporters. And then it's going to be on the bottom of this pipeline. Does it work? Yeah. At the bottom of the pipeline, where you have a pipeline section, where you have a logs, pipeline, metrics, traces, and you're going to have more, of course, where this is going to be saying, oh, what I'm going to receive and how I'm going to process. And you define the actual logic of your pipeline. So I think from the design perspective, there's no major difference. The logic is different, of course, because it's different tools. But you can basically do very, very complicated things in terms of processing. So I would say there is no clear winner on that round. So, round 2. Oh, gosh. Ah, better. All right. So what do you expect when you deal with logs? You need to be able to receive the most common protocols, meaning UDP, TCP, syslogs, Fluent Forward, which is a protocol from Fluent Bit, OpenTelemetry Collector logs, of course. You will have, of course, potentially Kafka involved. So this is, and of course, naturally, you're going to read from a file, no surprises. And both agent has the right support. You can, if you look at the repository on the plugin side, you can see, the collector has more plugins. But who cares? I can do 99% of my support with those plugins. And then in terms of what are the actions we want to do, we want to, of course, enrich those logs by adding some extra metadata. We're going to drop. We want to parser. We're going to batch. So both agent has the right support. The naming, of course, is not the same. When it comes to parsing, Fluent Bit has lots of parser. It's insane. And when it comes to regex, it supports Ruby regex, which is, if you're not familiar with that, it could be quite painful, but it works pretty well. And then on the OpenTelemetry side, it has OTTL, so OpenTelemetry Transform Language. And here, you can do very, very advanced things. It's just a design experience. If you're not used to OTTL, it could be difficult. But at the end, it's just a matter of learning curves. So here, I would say from logging perspective, if you look at the paper, there's no major difference. I would just say that I will give a shot for Fluent Bit. Why? You will see at the resource usage. So yeah, Fluent Bit is my favorite on that section. Round 3. It's much better. Oof. Let's hope I have 6 rounds, so then we'll have more attention. All right, so on the metric side, I need to receive metrics from different protocols. Same thing, collectd, statsd, OpenTelemetry metrics, Prometheus, host, be able to get metrics from the host for Kubelet or kubestat. The agent has the right plugins. I would say one downside of Fluent Bit is that it doesn't support scrape config on Prometheus, which means you can scrape, but then you have tons more work when it comes to processing. So that's one thing that could be improved. In terms of processing metric, what you expect? Yeah, of course, enriching the metrics, dropping the metrics, and then because metrics could be very, very expensive based on their cardinality, having the options to remove dimensions, that is required. And the other thing which is really, really, really important, I'm collecting data in different formats, so cumulative or stats or delta. And then I'm going to send it to a backend that supports one or the other formats. So converting metrics is like a must. Because we're going to get some Prometheus metrics. I'm going to send it to Dynatrace or Datadog. This supports delta, so I need to convert in the middle. So here, collector has everything. Fluent Bit has label processors to do renaming and dropping labels. Perfect. He has filters, but it doesn't have metric conversion. So for me, that's a really big negative point about Fluent Bit. So I will pick, obviously, the collector just for that reason. Round 4. All right, for traces, we need the common protocol, so open standard with OpenTelemetry. And then there's still out there old apps that emits Zipkin or open sensors, so having support of them is important. And also Kafka, because you'll probably go through a Kafka queue. So collector has what we need. Fluent Bit only have the proper support for OpenTelemetry, but it doesn't have the rest of the plugins. In terms of processing the traces, we are going to enrich those traces for sure. We're going to maybe reduce maybe some attributes or change the attributes that is going to be required. And then obviously we want to sample, because at the end, sampling through an agent like tail sampling, it's going to be what we need. So OpenTelemetry Collector, due to its nature, has every support that we need. So that's perfect. Fluent Bit here has a couple of content to adjust the resources. And then he introduced, since version 4, tail sampling and probabilistic sampling. So that is very exciting news, to be honest. So it can do the job for traces as well. But I would say for traces, I will still use the collector. Because for one simple reason is that when you do tail sampling, it's going to consume tons of memory, and you won't be able to load balance your traces based on trace ID, and it doesn't have a load balancer exporter. So you will stick to one instance, and the instance will grow in memory. You'll see when we touch base on the resources. Round 5. Oh, is it boring? All right, so let's go to the next slide to save some time. So I did a lot of tests, to be honest. To do those tests, I decided I'm going to test only with logs. where I'm receiving logs, I'm parsing, and I am enriching the logs. Then I do another test with logs and traces, where here traces I do nothing. It's just like a gateway. It goes through the agent. Then I do a test with log and traces and metrics. And for the metric side, I'm scraping, I'm adjusting some resources, and last I have a test where I'm doing focused just on sampling. For this, I have a GitHub repo with a QR code, and there's a branch for each version of Fluent Bit. So if you check, there's a branch for Fluent Bit version 4. The way it works is I have 2 demo apps, Hipster Shop and OpenTelemetry, and then I will do some load tests. If those apps have more load, they will naturally produce more logs, and they will naturally produce more traces. And then to increase the number of traces, I included Istio that will add extra spans on each transactions. And then I'm adding for the metric side very heavy, expensive exporters. So Kepler, amazing project, but very expensive. Istio has a lot of exporters embedded into the product. And then I'm using a couple of Prometheus exporters like Node Exporter, kubestat metrics, and so on. Here I'm using a daemon set deployment to start, to collect logs and everything. And you will see that for sampling, I will have to move to stateful set. And then for the collector, I did the same. I started with the daemon set. And you will see that I will have to change that. So this is just to show you the bad thing. And then we'll see what we should do later on. So starting with the first results with ramp up. So you can see the logs is increased by the load. So I'm doing 50 user added on every 30 seconds, every 30 minutes, sorry, on each app. So you have 200 user on the OpenTelemetry demo, and 200 user on the Hipster Shop. So in I would say in terms of the CPU resources, Fluent Bit is better. It's not super great compared to the collector, but it's better. We're consuming less CPU. It's about less than 100 millicore. And then, but it's in the memory, the difference. The memory in Fluent Bit, you don't see it, it's like 15, 20 megs. And the collector, we are more about 90 to 120 megs. So we have about an average of 80 megs difference between both of them. Then if I introduce the logs, the traces, sorry. You can see the traces on the top that increase with the load. I don't have the differences. Yeah.
What memory usage metric is that?
That's the working set. Yeah. And then so the CPU usage is the same, and then you can see that from a memory perspective, we still have the same discovery. Then if I start introducing metrics, yeah, then I saw that the collector was jumping in the roof, and I said, "Wow, something is wrong here." So I did a soak test, 24 hours, and a soak test, I jumped to 10 gigs, it crashed, and then it continued going. I said, "Whoa." So I opened a ticket about that. I said, there's a leak in the Prometheus receiver. And I said, okay. So maybe I'm going to check if it's really the metrics. So I did a test with only logs and only traces, only traces. And everything was stable on the collector. So I said, oh, it should be metrics for sure. And then here we have we were working together. So he said, I opened the ticket and said, oh, you need to generate some P profiles, which I did. So Braden is here, he's working for Google. He's part of Fluent Bit community and also OpenTelemetry. And then he says, oh, let's send me the P profiles, we're going to look at it. And he says, no, the problem is not Prometheus receiver, it's cumulative to Delta. And then he said, yeah, Henrik, you're stupid. You use the daemon set for doing cumulative Delta, and this is not the appropriate architecture. Oh, okay. So then I say, okay, let's move and do the metric conversion on a stateful set. So I did the same tests, one daemon set for logs, and then a stateful set for traces and metrics. Up, 24 hours tests, metric stable. So meaning that if you're doing metric conversion, please use the right architecture pattern. That's the conclusion. I'm looking at the time that we have left, if I can cover this section or not. I will go for. So how can we be more smart on the metric collections? Well, there is something in the Kubernetes operator of OpenTelemetry called the target allocator. To make it smart, you have your scrape config, target allocator is enabled. It basically takes the scrape config, send it to another service called a target allocator that will split the Prometheus jobs. And then every instance of your collector will reach out to the target allocator and say, oh, give you the metrics. So at the end, the collector is more efficient on that direction. And the plus is our support for Prometheus Prometheus CRD, so service monitors and pod monitors. And if I look at this resource usage, well, the metrics is more stable compared to the previous tests. And then the target allocator is consuming almost nothing. So at the end, if you have Prometheus, I will go for the target allocator. Now, let's go for sampling. What about sampling? So to do sampling, I did similar test. I did one daemon set for logs, one stateful set for traces and metrics, and then because Fluent Bit doesn't support the metric conversion, I had to use the collector. And then for the OpenTelemetry Collector, I have one load balancer on one instance that do just sampling decisions. And here I'm just showing you the actual usage of the sampling piece, so the stateful sets of each individual component. And here the test is a bit different. I have a stable load, and every 3 hours I make a spike. So you can see that we have 3 spikes. You can see that on the logs, and you can see that on the traces. And when you start using sampling, tail sampling, Fluent Bit, remember, it consumes about 20 megs. Here, we're almost reaching 800 to almost 1.2 gigs. So sampling is very, very expensive. And if you compare it to the collector, we have about 1.5 gig difference with the collector. Meaning that having the load balancer, you can at least reduce a bit the memory. Because you don't have it in Fluent Bit, it means your Fluent Bit instance is going to grow, and then you're going to cross the fingers it doesn't crash. So, meaning that, yes, Fluent Bit community, please add a load balancer, because otherwise we could be we're going to sweat when we're going to deal with that in production. Conclusion, I would say, so I compared the quality of the metrics that they're exposed, so I didn't touch base on this, the various pipeline and everything, but for me, I would say if you have to deal with high processing of logs, I mean, Fluent Bit is an obvious choice. A couple of megs, processing millions of logs, is going to do an amazing work for that. When you start to introduce metrics, yeah, go for the collector. If you have to start with the traces, I think Fluent Bit is going towards that directions. As of now, I would say use the collector. So, meaning that if you doesn't make sense to maintain 2 agents, because it's 2 different formats, 2 different skills. So if you go to start using the collector, yes, stay with the collector. And then if you're just dealing with logs, then use Fluent Bit, obviously. All right, small teaser on my YouTube channel. I will release in a few weeks, I don't remember, a dedicated episode about Fluent Bit version 4, so check it out. And I will share more numbers on that episode. And if you love the content, love it. If you hate the content, hate it, and let me know so then I can improve the content. All right, so if you have any questions, I would be love to answer any of your questions. Braden. So it's an excellent question. So what type of collector build I used for the tests? I was lazy. I was super lazy. I used the hotel contrib repo, and I used the version 0.126. And yes, the contrib collector has too many plugins. So you remember you have 90 or 100 megs. If you reduce with OCB and you build a custom distro, you could save some memory for sure. But yeah, I use the auto contrib.
Were you using the batch processor in the collector?
The question is, did I use the batch processor in the collector? Yes. So I use the batch processor because I'm sending it to a backend, and usually I size it depending on the rate limiting of the API that will ingest my data. So I was tuning it to be able to send the number of the optimized number of records to the backend, but I didn't optimize on that directions. But it could be a good if you have some tips on that, I'd love to hear about it.